A union B is equal to A union C. A intersection B is equal to A intersection C. How to prove that B is equal to C? See that taking that union, we took A union B is equal to A union C. Then we took intersection with B. So then we started with A union B is equal to A union C. Same thing, even if we start with A intersection C, A intersection B is A intersection C, still we can prove it. The thing is, if we start with intersection, then we have to take it union with B. If we start with union, take intersection with B. So this that is question number 3, and it was an asked question, repeatedly asked question. Exactly same. We have question number 11. See, question number 11. Even that last condition is not A intersection X is equal to B intersection X. It is given is equal to 5. Even if we don't need that condition, so it is equal to 5 around. A union X is equal to B union X. The question is to prove that A is equal to B. Question to prove that A is equal to B. See that here also, to show that A is equal to exactly same as that question what we did last class yesterday. We will start with union because intersection and union both are given. We start with union and take intersection along with this A. Our aim is to prove that A is equal to B. So to prove that A is equal to B, taking this union, take intersection along with A. So we start with this union. A union X is equal to B union X. Reason that is given. We started with union. Our aim is to show that A is equal to B. To show that A is equal to B, take it intersection with A. If it is to show that P is equal to Q, take it intersection with P. That's it. So taking intersection with A, this is A intersection A union X. This is A intersection B union X. We took intersection along with A on both sides because our aim is to prove that A is equal to B. See that we started with union and took intersection with A. Same time, if we start with intersection, then take union with A. That's also possible. This is better. A union X, B union X. Now, A intersection A union X. A intersection A union X is A only. Why A intersection A union X is A? Reason you have very clearly. A is a subset of A union X. A is a subset of A union X. Therefore, A intersection A union X will be A. See that if P is a subset of Q, if P is a subset of Q, their intersection will be P and their union will be Q. Remember, P is a subset of Q means P is a part of Q, or P is coming within Q. P is coming inside Q. Remember that Venn diagram. In Venn diagram also, P is coming a circle, P is coming inside another circle. So definitely the common region will be the smaller circle. All together will be the bigger circle. Exactly same. So if A is a subset of A union X, their intersection will be the subset A. Their union will be that full set. So A is this one. Right hand side we use distributive property. Again, distributive property also, remember, if you have difficulty in algebraic expression, we know distributive property. Here, intersection for into, union for plus addition. A into B plus C, we know A into B plus A into C. Exactly same. A into B, A intersection B, A intersection B, union A intersection X. Remember this algebraic expression. Algebraic expression, same thing as algebraic expression. Don't write in your answer, just keep in your mind if you have confusion. Now A union B. Now see that A intersection X, it is given. This A intersection X can be replaced with B intersection X. See that We started with A. Now our destination is to reach B. To reach B. So wherever here already B is there. Here there is no B. So try to get one B there. How to get that B? Because A intersection X is equal. So we replace A is equal to A intersection B union. This A intersection X can be replaced with B intersection X. Reason given A intersection X is equal to B intersection X. That is given. A is equal to. Now, taking B common. Again, if you have doubt, remember it. Intersection stands for into B, so A into B. Union stands for plus B into some C. A into B plus B into some X. Okay, B into X. In algebraic expression, if we take this B common, what do we get? B into, if B is taken common, A plus X, is it? B into A plus X. If B into A plus X, A into B plus B into X. So same thing. So here, if we take this B common into intersection A union X. Exactly same as algebraic expression. So if you have doubt, keep in mind this one we will get easily. B intersection. Now again, our destination is B. So wherever it is possible to change in terms of B. Now A union X. A union X can be replaced with B union X. So A is equal to B intersection B union X. Reason given A union X is equal to B union X. That is given. Again, B intersection B union X. A is B intersection B union X is B. Why? Because B is a subset of B union X. Therefore, B intersection B union X is equal to B. B intersection, whenever we have a subset and a superset, their intersection will be the subset, their union will be the superset. Remember. So this question also seen in examination. These two questions actually both are at the same time. What we did is we started with union and we took intersection along with A to prove that A is equal to B, right? So it's a good question. Now we'll do one more question, then we'll go to next chapter. See, question number 7. This question is also seen. I hope you have completed. So remember this. This is question number 3 and question number 11. 3 and 11 both are same type of questions. The method is same, the procedure is same. We started with union and took along intersection along with the set which is given. Now coming to question number 7. Again, that's not the same question. Not question number 7. Question number 6. Question number 6. Question number 6. P of A is equal to P of B. If P of A is equal to P of B, show that A is equal to B. P of A is equal to P of B. Show that A is equal to B. The meaning of P of A. P of A is the power set of A. Power set of A means the set of all subsets of A. Remember that whenever we write a set A, then power set of A. See that the elements in this power set of A will be sets only. In power set of A, If this is P of A, 1, 3. If you write P of A as 1, 3, 5, at once you can say that this is a wrong statement. It is wrong. It is not possible. The reason, the elements in power sets, are all sets only. We will not get one element, a number in a power set. The elements or the members of this power set, will be again set. So set this is possible. Set 1, this is possible. This elements. It will be, so remember, whenever we get power set, the power set may contain only set. That means A belongs to power set of A. This statement is a wrong statement. A belongs to power set of A is a wrong statement. We have seen that. A belongs to A can be true. A belongs to A. This can be a true sentence. It can be a true statement. It can be an element, but A cannot be an element of power set. Then how to correct it? This can be corrected in two ways. Either does not belong to or set A belongs to. Now it is corrected. This is correct. Set A belongs to P of A. See that A belongs to power set of A is wrong. So remember this. Whereas this one, set A belongs to A. That can be correct. It can be correct. The reason, in a set A, if you are writing 1, 2, set A, that is correct. Set A belongs to A. So set can be a member of a set. It is possible. But an element can never be element of a member of power set. In power set, all the elements will be sets only. Now, to show that A is equal to B, here we use that method. We discussed in the beginning. To prove that two sets are equal, to prove that A is equal to B, it will be sufficient if we prove A is a subset of B, then B is a subset of A. If A and B are subsets of each other, if A is a subset of B and B is a subset of B, then A and B are equal. We wrote it in the beginning. So again, to show that A is a subset of B, again by definition, to show that A is a subset of B, then if X belongs to A, that implies X belongs to B also. X belongs to A, that means any element belongs to A, that implies that element is also in B. If so, we can say that A is subset of B. Remember the definition of A subset of B. If A is a subset of B, that means X belongs to A implies X belongs to B. This definition also we wrote in the beginning, A subset of B. If X belongs to A implies X belongs to B, that means A is a subset of B. So what here, to show that A is equal to B, first we will prove A subset of B, then B subset of B. For that, we start with X belongs to A. X belongs to A. Starting with X belongs to A, if we can reach X belongs to B, then definitely X belongs to A implies X belongs to B means then we can write A is a subset of B. So X belongs to A. This implies if X belongs to A, definitely set X belongs to power set of A. In set A, if X is an element, then definitely set X will be an element of power set. See that here, this braces, number, everything is very, very important. X belongs to A. In the next step, in examination, few people used to write X belongs to. Then after doing everything, they will come to us with the paper. Sir, you cut marks unnecessarily. Why? Sir, only one bracket is missing. And you cut everything. You cut marks. only bracket. It's a small mistake. I made a small mistake. Then you'll say that also. I made a small mistake. What is a small mistake? I forgot to put a bracket and said it is totally wrong. See that bracket in maths, brackets means it is a lot. Bracket plays an important role. See, 2 in maths, 2x squared and 2x whole squared. There is a lot of difference. 2x squared means 2 times x squared. 2x whole square means here x is multiplied 2 times. X is multiplied 2 times, then it is twice. Whereas 2x whole square means 2x is multiplied 2 times. Like, you know that comma. In English language, comma plays very important role. I think you know that story. Once A killed a person called B. A killed a person B. The case came to the court. And you may have seen in movies also, you may have seen 2 advocates. One for A against A. At last, this person for the advocate for A, he said that no, A killed B, and he produced hundreds of evidences, witnesses. At the same time, the other one said that at the time of his father, he was not at all there. He was abroad. He produced passport, the ticket, everything. At last, the judge was confused. The judge wrote the verdict and him not let him go. Hang him not. The meaning of this in English language, the meaning of this one, hang him not, let him go. Again, it is confusing sentence. If a comma is here, hang him, not let him go. Hang him, not let him go. That means he is culprit. Whereas if the comma is here, hang him not, let him go free. See, a difference in comma. A difference in comma costs a life. So in English language, comma is very, very exactly same. In our maths also, bracket plays an important role. So if you put wrong bracket, that means it is wrong. Again, in set we learned open bracket, close bracket. Again, brackets also different types are there. Open bracket, open interval, simple bracket, closed interval, square bracket. Whereas last year in class 10, sometimes you used to put this one, or sometimes for making it style, this one. We used to select any bracket anyway. No? But this year, remember, this is open interval, closed interval. So even bracket plays a role. So what we said is x belongs to A implies set x belongs to power set of A. It should be set x, not just x. This implies set x belongs to power set of A. We know that power set of A is equal to power set of B. Power set of A can be replaced, reason, given power set of A given P of A is equal to P of B. If set x belongs to power set of B, that means x belongs to B. Because if set x is inside power set of B, x belongs. So we started with x belongs to A implies x belongs to B. Therefore, A, that's the definition of A is a subset of B. Condition number 1. See that taking an element x in A, we proved that it is an element in B also. So x belongs to A implies x belongs to B means A is a subset of B. See, so we proved A is a subset of B. Now the task is to prove that B is a subset of B. Take an element. Y belongs to B. Y belongs to B means set Y belongs to power set of B. This implies set Y belongs to power set of A. Reason given power set of B is equal to power set of A. This implies Y belongs to A. So Y belongs to B implies Y belongs to A. Therefore, B is a subset of A. Condition number 2. Taking X belongs to A, we prove that it belongs to B. So A is a subset of B. Taking Y belongs to B, We proved that Y belongs to A also, which shows B is a subset of A. Now from 1 and 2, from 1 and 2, A is a subset of B and B is a subset of A. If A is subset of B and B is subset of A, we can write A subset 1 and 2, A subset of B and B subset of A. It is not C subset, denominated C. This implies A is equal to B. This question is also seen. These three questions are seen in examinations. That is question number 3, this question number 6, and question number 9. Remaining questions, we discussed few questions. Remaining few I gave homeworks. Then go to the remaining questions. Okay. Okay. I'll give a minute. So write it. Set X belongs to A. I mean that set X does not belong to power set of A. Yes. We discussed it. It can be. We discussed. We wrote at the beginning. Okay. I hope you are completed. We said that at the beginning. See, X belongs to power set of A is completely wrong. Then the correct thing is X belongs to power set of A is completely wrong. The correct thing is set X belongs to power set of A. This is correct. X belongs to power set of A. X belongs to A is correct. X belongs to power set of A is wrong. X belongs to A is correct. But see that set X belongs to. This is also true. We set an example. Reason in set A 1, 2, 3. Set X 4. Can be. It is possible. We discussed it. So X belongs to even as that can be an element of it. No problem. But in power sets, a number will not come always A sets. So that's all regarding sets. Remaining questions, try by yourself and we'll give some extra questions in the group. And that questions also you have to do by yourself. If you have doubts, we will do it later on. Before examination, we will do it. Now coming to chapter 2, relations and functions. Relations and functions. In fact, this one, relations and functions. It's an easy chapter, but very important chapter. Like see, even sets also you may have observed it. It's an easy chapter. It is not that hard. Sets, relations and functions. Actually, all these chapters are just basic introduction of the portion what we are going to learn this year and next year. Everything is based on relations because we will get functions later on. All functions are relations or relations. And every relation also is coming from sets. That's why it started from sets, then from sets relations, then from relation functions, then different types of functions will get. Okay. Now, relation. See, before relation, I will write two sets. A is equal to 1, B is equal to 3, 4, 5. I have two sets A and B. Now, see, we learned a product called A cross B. We will not read it as A multiplied by B. Being said, it is A cross B. We call it as a Cartesian product. A cross B. A cross B is nothing. It is the set of ordered pairs. The set of ordered pairs. You know what an ordered pair is. In class 9, you learned. Ordered pair means this is an ordered pair. Why is it called an ordered pair? Because order is important. X, Y, and Y, X. 2, 3. Ordered pair 2, 3 and ordered pair 3, 2. They are different. No, one of you asked me to do. No, again, which one sets again, we cannot revise everything because let's go once again because my network somewhere started to lag. Which one sets again, we are no, that you later on we can discuss. See, A cross B. The ordered pair 2, 3 and 3, 2, they are different. Ordered pair means the order is important. You know the meaning of 2, 3. In class 9, you learned the Cartesian coordinates 2, 3. 2 is the x coordinate. This means 2, 3 represents a point in the Cartesian plane. X coordinate is 2, y coordinate is 3. You know the position of 2, 3. See, the position of 2, 3 and position of 3, 2 is entirely different. So the ordered pair 2, 3 and 3, 2 is entirely different. Whereas set 2, 3, set 2, 3, set 3, 2. They are saying set 2, 3 and set 3. See, the difference in bracket makes a lot of difference. This both are same because we know that in sets roster form, the order is irrelevant. Whether we write 2, 3 or 3, 2 doesn't make a difference. Whereas in ordered pair, 2, 3 and 3, 2 makes a lot of difference. That denotes entirely two different points in the Cartesian. That's it is called ordered pair. So ordered pair x, y. And you know the first one, this is x coordinate, y coordinate. You know the other name of x coordinate, axis and ordinate maybe. Those all you learn along the Now, A cross B means the set of all ordered pairs, the set of all pairs, so that the first element, the x coordinate has to be taken from A and y coordinate taken from B. So A cross B means, so take 1, 3, 1, 4, 1, 5 in an order. 1, 3, 1, 4, 1, 5. Then 2, 3, 2, 4, 2, 5. This set of ordered pairs, this is called A cross B, or the cross product of two sets, or the Cartesian product A cross B. The set of all ordered pairs. So here we have taken the set of all possible ordered pairs, so that in that ordered pair, the first number is taken from set A, second number is taken from set B. Whereas when we take B cross A, when we take B cross A, by definition, if it is A cross B, the first element has to be taken from A, second element has to be taken from B. If so, for B cross A, the first element has to be taken from B and second element from A. Like we start with B. Taking with B, the first element 3. 3, 1, 3, 2. It is 3, 1, 3, 2. Starting with 4. 4, 1, 4, 2. Starting with 5. 5, 1, 5, 2. These are the pairs in B cross A. See that A cross B and B cross A, both are having ordered pairs, but see that the ordered pairs are different. Ordered pair 1, 2 and 2 are different because the order is important. So definition of A cross B is we take all the set of ordered pairs x, y such that x belongs to A and y belongs to B. This is the definition. So write definition. First write definition. Given two non-empty sets A and B. Right. Given two non-empty sets A and B. Given two non-empty sets A and B. The Cartesian product. The Cartesian product. Cartesian product. Cartesian product A cross B. See that we read it as A cross B. Cartesian product A cross B is The set of all ordered pairs is the set of all ordered pairs. The set of all ordered pairs from A to B. The set of all ordered pairs from A to B. Set of all ordered pairs from A to B. Set of all ordered pairs from A to B. That is, A cross B is equal to, right, set. This we read in Senate, we read as set ordered pair xy such that x belongs to A, y belongs to B. Set ordered pair xy such that x belongs to A, x belongs to y belongs to B. This is example. Example, write this example. If A is equal to 1, 2, B is equal to 3, 4, 5, write A cross B. See that for A cross B. Okay, this is after definition only we have an example. You wrote example. See, whenever I explain something, listen to it. I will give you time for writing. I will give you time for writing. Now, from just another one. Example, A is equal to 1, 2, B is equal to 3, 4, 5. See that for writing A cross B, we started with elements in A. Starting with 1, 1, 3, 1, 4, 1, 5. That's it. 2, 3, 2, 4, 2, 5. Whereas B cross A, starting with B. 3, 1, 3, 2. 4, 1, 4, 2. 5, 1, 5, 2. That's it. So A cross B and B cross A. I think within 1 or 2 minutes, within 1 minute, the meeting may end. Again, log in with the same ID. And next one. So after writing this one, now we will write some properties. In fact, these are easy one. Even if without writing, you can make it up. First one. Write it. 2 ordered pairs are equal. 2 ordered pairs are equal. 2 ordered pairs are equal if and only if 2 ordered pairs are equal if and only if the corresponding elements are equal. If and only if the corresponding elements are equal. Then you know, see this means if xy is if xy is 2, 3, if these 2 ordered pairs are equal, what's the value of x? X will be 2, y is 3. Because corresponding elements. If they are equal, then only we say they are equal. You learn in lower class. Next one. Next one. If n of a, if n of a is p, n of b is q, then n of a cross b is pq. Then you can observe that example. We have taken 2 elements in set. In the example, we have taken 2 elements in set A, 3 elements in set B. Then A cross B will have 2 into 3. You can observe it. 6 pairs